Hello, Math 98. This is Gary Parker. I hope your work this week is going well, playing with lines and rates of change. Just a brief overview of what's going on this week. So the big ideas this week are linear models, which we've been playing with since the start of the course. Linear model is an equation, like y equals mx plus b. And we often think about that as a graph. So I have an x-axis, which is horizontal, y-axis is always vertical. And then maybe this is my line, right there. This line has a starting point over here, and it has a slope. Slope has rise, and slope has run. So that's my m here. So m, our slope, is always the rise divided by the run. Now here, I'm running positively to the right, and I'm rising positively up. So if both numbers are positive, the slope is positive. But it could be we have a downhill decreasing trend like this right here. And it's possible, in this case, I have a positive run, but a negative rise. So this would be positive, negative. So when I found the slope, it's always rise over run, in this case, a negative number over a positive number, which is going to lead to a negative slope in the end. When we have a negative trend in the slope like this, that's called decreasing. And when we have a positive slope like this one up here, that's called increasing. And the slope here is often referred to as the rate of change of the situation. And so I'll explain more about that in just a moment. Now that rise I'm looking at here, I started down here at this y value, I moved up to that y value. So that rise is a change in your y values. And similarly for x, I started over here at some x value and ended up over there at some other x value. So I changed from one x value to another. So that run is what we call a change in x. Oops. Sorry about that. And there's a formula for that if you have 2 points, which you'll get to play with later. So this could be 1 point right there, that P1.1, and this one would be 0.2 over there. And each point has an x value, usually call that x1 for the first one, and y1 for the y value. And the second one, that point would be x2 comma y2. Right? So here's the first x and y value, here's the second x and y value. So the formula for slope, if you happen to have 2 points, sometimes we're just given the slope depending on the situation, would be find the change in y. Change means subtract. And then find that change in x. Change means subtract. And so up here, when I was talking about the rate of change, the rate part is the division. When you divide two things, you make a rate. And then the change part, that's the subtraction. So we're doing that there. That's why slope is called the rate of change. Rate of change could be something like miles per hour, right? We're used to talking about that. Example of a line maybe here. I like to mountain bike, and generally I bike uphill, and the bike trails I ride are about 1 mile from my house. So if y was like the distance I biked from my house, then my equation might be y equals 7x plus 1. And so let's see, figure out what that means in this case. So my slope, m, is my rate of change, and this is my starting point. So x here, I'm going to take to be my time biking in hours. And y is just, we'll do a real simple example, just distance from my house. And let's say that's in miles. When I find that slope, which I'm claiming is 7, I could write it as a fraction by saying 7 over 1. The numerator, right, is the change in y. So that would be a change of 7 miles. The denominator is a change in x. X is hours, so that would be 1 hour. So what the slope is giving me here is my average speed in miles per hour. So interpreting the slope in a situation is important. So I could tell somebody, well, this is just like my average speed when I bike. It's kind of slow because I bike uphill and dirt and gravel. The b is 1 in this case up there, and the b is often referred to as the y-intercept. It's this point right here on the axis. And at that point, I haven't really gone left or right from the y-axis, so x is 0, and y is whatever that number is. So the y-intercept is a point. So in this case, x is 0, so that would be 0 hours. And y is 1, so that'd be 1 mile. So that 0 means when I start, I'm 1 mile from my house. So that would be the interpretation of that y-intercept. And sometimes y-intercepts have a reasonable interpretation, and later we'll see sometimes they don't. Just kind of depends on the situation. Starting 1 mile from my house. So this week, you're going to play around with, given some information, maybe you're given the slope and the y-intercept, and then we write an equation, and we use the equation in different ways. But other times we're going to give in 2 points related to the situation, and then based on those 2 points, we're going to come up with the slope by finding the difference in the numbers and coming up with the slope. So for example, maybe this first point over there, let's get a new page. Maybe my first point is 1, 8. And my second point is, how about 3, 22. Often, if I need to find the slope between those 2 points, I like to graph them. So I would make a rough graph of this. And on my graph, I need to be able to see x equals 1 and 3. You know, that's no big deal. Maybe that's 1, 2, and 3 is right there. So there's 1, there's 3 for x. And then I get all the way up to 22. So, you know, maybe way up here, I'm going to put something like 25. So maybe I'm going to go for this one. I might do 5, 10, 15, 20, 25 would be up there. It doesn't have to be perfect, but graph paper helps too. All right, 5, 10, 15, 20, 25. Okay. And then I had the point 1, 8, so that would be around here-ish. And then 322 is going to be about here-ish. So I'm trying to find the slope between these 2 points. And so in the picture, I can kind of estimate it by just looking. I can see, oh, well, I'm going from 8 here up to 22 over here, right? And so I can figure out what that rise is. Let's see, I guess I need to write that down. What is 22 minus 8? On a good day, it is 14, I think. So I think I'm going up 14, and then I'm going to go to the right that way from 1 to 3. Well, that's pretty easy. That's just 2. 3 minus 1 is 2. My slope is 14 over 2, which I can reduce to 7 over 1, or more simply just 7. So there's my slope right there between 2 points. And again, it's your y values subtracted in the numerator and your x values subtracted in the denominator. And important things, again, y's have to be in the top, x's in the bottom, and then your points should line up vertically, right? Here's my point 322, here's my point 18. Other thing that we'll look at this week are intersecting lines. straight axis was that? A little better. So maybe we have one line that heads up kind of like that. And we've got this other line that's maybe a bit shallower like that. And we want to figure out where do they meet. And we can draw the graph and kind of see that sometimes. And we can solve an equation. So here's a super simple version of solving an equation. Let's suppose that the green line is y equals 1/2 x plus 2. And the red line is y equals x plus 1. If I want to find this point of intersection here, I can just set these two equal to each other. So when does x plus 1 equal 1/2 x plus 2? So I just set them equal to each other because they're both y equals, and then do my best to solve this. So the easiest way to solve this one, I think I would subtract the 1 over to the other side. So then I get x equals 1/2 x plus 1. And then I would have to subtract this 1/2 x over. And remember, an x is really a 1x. So I have an x, I lose half an x. That means I should have half an x left. And to get rid of a multiple of 1/2 here, I would times by 2, because 2 times 1/2 is 1, 1 times x is just x. I'm going to do the same on the other side. So it looks like they meet when x is 2. And I can always plug back in to check. Right? If I put a 2 in for x here, 2 plus 1 is going to give me out 3. If I put a 2 in for x there, half of 2 is 1. 1 plus 2 is 3. And so they match. They meet at the right spot. So I think they meet here at 2, 3. It's the point of intersection. My graph's pretty messy there, so it's hard to tell. No numbers here either, right? But my point here is sometimes we have two different situations. We want to know when do they meet up? And we can look at a graph and try and solve it. We could use an equation to try and solve it. And in some other videos this week, you'll see you can use a spreadsheet to try and solve it. So take care, do good math. One other thing, two other things I wanted to mention. When you're working on your homework assignments, if you open it up and it's after the due date, oops, I should get in the student mode here, you'll receive a couple of options that you didn't see before. One is redeem a late pass. A late pass lets you work on it and improve your grade. The other is practice. And if you look at the fine print here, it says practice is ungraded. So the reason I have these options here is often to prepare for a test, we go back and look at previous homework. And practice mode lets you go back to work on homework that you've already done, but you could redo it without messing with your grade. However, if you needed more time to finish an assignment, like it was due yesterday and you need another day or two because you're still struggling with it, then redeem a late pass. I give you 20 late passes. Usually that's more than enough for most people. And then I have special events where I'll give out some extra if you happen to use them up. So keep that in mind. So let's see, I don't have a very good grade on this at the moment, which is a 0. So I better redeem a late pass so I can work on it. Other thing I wanted to remind you of is when you're working on a problem, there's always this message or instructor link. So please feel free to use that when you're stuck. So if you spend 15 minutes on this and you're not figuring it out, that's too long. A specific question shouldn't take that long. Message me, ask for help. I'll get back to you with some written text or video, or we can schedule a meeting time. So please stay in touch, do good math, let me know when you need help. That's it for now. Have a great day. Bye-bye.